station, this is Houston. Are you ready for the event?
Yes, we are ready for the event. We don't have the handheld mic, but we are ready.
WeatherNation, this is Mission Control Houston. Please call station for a voice check.
This is WeatherNation, meteorologist Meredith Garfalo for voice check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How do you hear me?
We have you loud and clear, Meredith.
Excellent. Well, let's get the show on the road from Earth to the space station. Thank you so much for joining us. We are very excited and honored to have two of our astronauts on the International Space Station joining us. We have NASA astronaut and retired U.S. Army Colonel Mark Vande and European Space Agency astronaut Thomas Pesquet of France. How are things going more than 200 miles above Earth?
Meredith, they are going fantastic. We're getting a lot of work done every day, and we're having fun with each other. Good work and a lot of laughs as well.
That's good, because we can't take life too seriously, right? And especially when you are watching it from above. One of the questions I always get when I'm talking about the space station and astronauts that I'm sure you'll love to answer for us, and people across the entire planet would like to know, is what is it like calling the space station your home, to be up there where you live, work, and breathe?
Oh, it's absolutely fantastic, Meredith, and for both for Mark and myself, it's the second mission, so we really get to call it home because we've lived and worked on the space station a lot of days, more than 200 days, I think, both of us. So it feels like home. It means you get used to it. Things are a little bit different up here, as you see. We're floating, so it makes daily life sometimes more complicated when you have to eat, when you have to, shower. But sometimes it makes it easier. In the morning, you just have to jump into your pants, for example, which you cannot do on Earth. So it takes some getting used to, but it's really fantastic. It's a new environment that your body adapts to, that your mind adapts to. You live in 3 dimensions, and then you never get tired of the view.
I was going to say and ask you guys, can you do backflips? Have you mastered that now on your second mission in space?
It just so happens that Mark right here is the grand master of backflips, so he's going to demonstrate. Look at this.
Wow.
Very nicely done. It's like the Olympics of space.
Hey, who knows? Maybe in the next decade we will have Space Olympics, and you guys are already ready for that. I'm a scientist, a meteorologist here at WeatherNation. I find all the work that you're doing in space absolutely fascinating, from the research to all the experiments, the topics you're studying, human anatomy, botany, space weather, and microgravity. What have you personally worked on during your first mission, and what are you looking to accomplish now on this current trip?
I have to think about the previous mission. I've been very focused on the current mission and the celestial immunity experiment we've been doing. One of the challenges with simulating human systems on the Earth, as you're well aware of as a meteorologist, are the forces of convection and buoyancy have a huge impact on the surface of the Earth and the atmosphere of the Earth. Up here in space, those effects are very minimal as we're in a free fall around the planet. So we're taking advantage of that because we can better study 3-dimensional systems like human cells. We're taking advantage of that to study the immune system with this experiment, celestial immunity, that we've been spending a good chunk of every day in the last week or so working on that.
That's so cool how you passed the mic. I just have to put that out there. Thomas, how about for you?
And for me, there's actually a nice experiment that's called Grip and Grasp. It's a European experiment that I commissioned last time I was here 4 years ago, and to them the last subject. So I'm kind of closing the loop, and so it's kind of nice to have followed this experiment from beginning to end. And it really looks at the way your brain is wired in space, because being in space is a learning experience. It's like learning how to ride a bike, and then you can't forget. And there's not that many examples of such a rewiring of your brain for an adult. And by looking at what happens when you interact with your environment in space, then scientists find out new connections in the brain, and then it can help cure people with disabilities and things like that on the Earth. So this is an experiment I took a lot of pride in, and very happy to conclude the cycle of this experiment today.
That's very exciting, and we look forward to seeing the research that comes out of it in the future. As you know, here on Earth, we rely on satellites to get weather information. And for you up in space, what type of Earth remote sensing instruments are currently operating on the space station, and what are they studying?
So there's a few experiments looking down at the Earth and looking at the atmosphere. One that I particularly like is called ASIM, or ASIM, A-S-I-M. It's actually European-made, Danish-made even, and it operates on the outside of the space station. It looks at the phenomena that happen in the upper atmosphere whenever there's a thunderstorm. We got what we call sprites or elves. Those are electrical discharges in the upper atmosphere. You can actually see them from the space station. We were talking to Megan, one of our crew members. She saw one yesterday, and it looks like it's really cool. It looks like a blue kind of a electrical discharge, but that goes vertically up from a thunderstorm instead of going down to the ground. And this instrument is tracking them and performing some kind of a survey. And it really helps, as you know, as a meteorologist, understanding what happens in a storm cell and help to deal with them on the ground. So that's one that I really like.
You get to observe our planet every single day for more than 200 miles above. What unique phenomena have you both seen and observed that you can share with us? We know we have typhoons. During the tropical season, we have hurricanes.
Meredith, on my last flight, I got to see a hurricane. Of course, those are devastating on the ground. Up here, it's hard to believe that something that looks that beautiful is causing that much damage. Just recently, when we were traveling over Central Africa, I saw thunderstorms, lightning storms. From space, you can see so many flashes of lightning all over the place. It's a very unique experience to be able to get that view, and it's shocking how broad and intense those electrical storms can be.
And how about for you, Thomas?
Yeah, I can only agree with Mark. Thunderstorms at night are actually wonderful. They're really cool to look at. Almost impossible to take a picture of. I've tried, trust me, but I still have some time on this mission to try to succeed. And obviously, tropical storms are a big one. If you see some pictures that were taken by, I think, a colleague not so long ago, you can look straight down into the eye of the storm, which is hugely impressive. You see those massive walls. They're kilometers high. I don't exactly know how many. But they really look like cloud walls, and then you look straight down from the space station with a big lens, with our biggest telephoto lens. That's one of the most impressive pictures I've ever seen taken from the space station.
Well, I would love to trade places with you and be able to see that myself, being a science and space geek. Let me ask both of you this. You had careers before you became astronauts and gone up to space. What has it been like being an astronaut? What makes that different from your previous careers?
It's a great question. It's a question we generally love to answer to try to help out the kids who are trying to decide what to do for their future. Mark has really good advice, so he's the one who's going to answer that question. For me, it's really just don't limit yourself. Don't censor yourself. I almost didn't apply for the astronaut selection because I didn't think it was something I could do. And just a friend of mine told me, no, you should. You know, you're a pilot. You're an engineer. You should try it. And I was like, hey, he's right. But I almost didn't do it, and I would have been the biggest mistake of my life. So just try things. Maybe they succeed, maybe they don't. But every time you try something, you take a step on the path, and maybe it's not going to lead you where you thought it was going to lead you. But it's gonna revolve. You're gonna find out what's happening. You're gonna find new crossroads if you engage and if you start on that path. So just do it. Don't be scared, and something's gonna come out of it.
Yay. Megan's demonstrating our flying through space for us. Yeah, I would add to that by saying, much like what Tomas said, do things that risk failure. Even if it's possible that you might fail, give it a shot. Also, always do your best, but put more emphasis on all the people around you that you're working with doing their best than you always being the best of the group. So you got to be a team player as well.
That's great to hear, and I'm sure a lot of young boys and girls are looking forward to becoming astronauts down the road, and hearing that from you and from the other astronauts is just very motivating and inspirational. I've asked you guys a lot of hard questions, so how about we have some fun? What do you guys do for fun when you're not doing research or conducting experiments?
So the good thing is we're all good friends here on the crew. We're from the same class with Mark, and we've trained together before. We've had underwater missions before. I flew with Shane. We had missions with Aki, so we all know each other, which means there can be some fun in the evenings or on the Sundays when we're not working. Everybody's taking pictures sometimes, looking at the Earth. Some people write a journal or a diary. You know, they might want to write a book later on. People are reading. People are sometimes coming up with fun games to play that actually use the environment of microgravity. And Mark has a few ideas. I don't want to throw him under the bus, but he's actually really good at finding out good fun ideas to do in weightlessness. So really, there's a lot that you could do. Obviously, it's a confined environment, so you don't go out for a walk, not so often. But everything that we can do, and we're trying to make use of that environment to do things that you cannot do on Earth, like double backflips, and we practice this on the weekend.
Hopefully I'm not going to get in trouble with sharing this game, but we played a game with the previous crew where, as you can see, the space station is really long. There's a long path through here. And I called it human darts because we would have somebody push off the front end of the space station and try to see how far they could go before they'd make contact with any surfaces. And some people were really impressive. You have to be very, very precise and do a lot of gyrations as you're trying to avoid making contact with anything. But that was a lot of fun. Like Shane just demonstrated quite well, even though he didn't even know he was playing.
Well done, Shane. Well, I'm impressed here. I think that's a game I would like to try sometime, you know, down the road, maybe when we all get out to space. But one of the things that we always talk about here on WeatherNation is the difference we're going to make for the Artemis generation and for the next decades to come with the space exploration program. What do you hope that on your current mission they can take to put toward going to the moon and eventually going to Mars?
It's a great question, and it is true that we're doing science and research on the space station that benefit the Earth, and this is like part of our goals. But we have also bigger goals, longer term goals, and one of them is to go forward to the moon and go to Mars. And for that, we have a wide array of experiments that we're doing as well to prepare experiments and tech demo to prepare those missions. One of them that I was doing not so long ago in a Columbus laboratory is about, again, how do you pilot a spacecraft or a rover on a distant planet? Like, you would be orbiting in a space station or in a spacecraft around the planet and remote controlling some assets on the ground. This is one of the scenarios for future exploration, and we're preparing this today on board the space station.
And how about for you, Mark?
Actually, even understanding how to have the human body perform well after being in orbit for months at a time is part of the experiment for us to be able to explore further and further into the solar system. We have the benefit of return to Earth and having medical support as soon as we return, but of course it's very important in the future that when people get to places where they're establishing human presence for the first time, that we understand how they'll be able to perform after a really long trip in an environment probably smaller than this, but certainly with the same type of free fall environment that we're in here. We've got regenerative systems that we're using all the time that help us recycle all of our water. Thomas mentioned demonstrations. We're getting ready to install a new toilet that should help us understand better how future systems or improved systems to use for future spacecraft.
Hey, a better toilet benefits everybody, right? Thank you so much, Tomas and Mark, for joining us. We are very appreciative of everything that you and your teams are doing. And I don't know if you can go out with a double backflip if that's possible, but we appreciate everything you've showed and told us today.
So, thanks, Meredith. It was a pleasure talking to you from the space station, and we'll keep looking for those weather phenomena when we look outside the window.
Thank you guys so much. Yes, we appreciate it.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants from WeatherNation. Station, we're now resuming operational audio communications.